let's have some introduction for the AI subject. I don't believe that for now AI will take will make a replacement for human workers in the industry, but those who possess the skill to use the AI will definitely will. So I do believe that the future is embracing the AI and applying it in all of the fields. Of course, we are far away from singularity. We can see here the singularity concept. For you that don't know what this concept means, the singularity is the moment when the artificial intelligence will be above the human intelligence. We are not there yet, but we are not far. I would like also to start with a funny story. In 2019, I was pitching for the Canadian company at the Startup Grind event in London. And then we went near the London Eye to take some oysters. And the lady, which was selling oysters, I have a picture with her, she was asking me, what are you doing for a living? And we were very happy and enthusiastic. And we told her that, see, we are doing AI, like we are so great. And the lady who was selling oysters to us, she was asking me, supervised or unsupervised? So I was a bit shocked because I was not expecting the lady to ask us such a question. So be aware of AI. The oyster lady was from 2019. So coming back to an AI perspective, this is also something that I heard in Dubai at Expo. People were talking about generation zero. So we are now dependent on our phones. We are actually, we cannot live in the modern society without a portable memory, without a portable tool, which carry for us the information about us and for us. So basically, they used to call us now the generation zero of cyborgs. We don't have the external memory implemented yet, but we are dependent on it. So coming back on the singularity, this is just my belief, but on the right part of the screen, you can see that there is the Turing test. I think part of you know the Turing test. If a machine passes some results to a human C and also a human passes the result to a human C, if the person who receives the results cannot make a difference between A and B, then we can discuss about getting closer to singularity. But what I do believe that the singularity is reached only when the paradox of the Turing test will be accomplished, and the paradox of the Turing test is when the machine will fool the human that he's not able to answer the question. Actually, it can't. So I will talk some generics about this large field. I will split my my presentation in some fragments for each domain. These are actually very large domains to talk about, but I will be very generic. So I found this like very interesting, exclusively also for our new colleagues, which are starting to work now in the field of AI, because it's important to see the bridge between data science, computer science, statistics, where AI is, where machine learning is, where the big data is, and when the deep learning is. When I started the PhD, I was not able to get so much structured information. So I will start then to talk a bit about data mining, because this is the large field of data mining, which includes the big data, AI, predictive modeling, and so on. So the data mining is, as I said, an integration of all of those. It represents the data cleaning process, the data integration, evaluation, and interpretation. You have to take the data, you have to clean it, you have to combine the data from multiple sources. And this always, and sometimes, but nowadays, always involves applying various statistical and machine learning algorithms. Where is the big data? So I heard this question like a lot lately. What do you consider to be big data? So of course, what was big data yesterday is not today, and what will be big data tomorrow, it's not gonna be today. So as for now, we stand from few hundred gigabytes to few petabytes when we discuss about big data. And the big data, I would like to describe it using the three V's: the volume, velocity, and variety. So the volume, it's quite easy to understand what big data means. It's often the data which cannot be stored on the computer memory. The velocity is the big data generated at high speed from different sources. So this will come at one end from many parts. And also the variety. Now the data centers can have many sources of data, which include the database structured, unstructured. So there is a challenge for the big data to collect everything. Okay, so if we have big data, then for sure AI can help us with doing this process and sort it and clustering, classified, and predict it. So I did this classification. It's important to see that the deep learning is only a part of the artificial intelligence, and we call artificial intelligence algorithm. Have all kinds of algorithms which are able to do human intelligent tasks, like recognizing patterns, like making decisions, or learning from the experience. Going from the general AI, that any technique that can learn, we go further to machine learning and so on to deep learning, where we have the neural networks and of course the big elephant from the room, the ChatGPT, which is also deep learning. So some applications maybe of the AI, I saw also in the last presentation, very great applications of AI in engineering. So I consider that I should just remember some parts where it can be applied. It's important to know that machine learning can do unsupervised, supervised, and reinforcement learning. And now you are maybe asking yourself, if I'm doing an engineering task, which of this should I use? Well, the answer is simple. How is your data? I think our colleague also mentioned this. Your data, how do you want to get the results out of it? If you want to do some predictions, then you should do supervised learning with regressions. If you want to do image classifications, then you should do supervised learning with classification. For unsupervised, if you want to do big data visualization, you should use unsupervised learning. And if you want to, I don't know, just do some AI games and real-time decision, maybe the reinforcement learning would be the best, because it can learn real time from the experience. One part of the data which is important in this machine learning aspect is that for the unsupervised learning, the correct output is unknown. For the supervised learning, the correct output is known for each input. And for reinforcement learning, the model learns by trial and error. One example of reinforcement learning would be placing an AI robot or tool or algorithm inside of a football terrain and let it play with the ball. If it scores, then he will gain a good mark. If you take the ball outside the terrain, then he will get a fault. So he will learn the rules of the game just by playing with the ball and getting some scores. Okay, another buzzwords recently, which we all can hear, is the blockchain. Blockchain, what is blockchain? Well, In simple words, blockchain is just a database. That's it. A database or a ledger. Of course, it's a special database, which is decentralized, which make it special. Nowadays, all the databases that are keeping the informations are in data centers. And if something is going to happen to those data centers, of course, our access to the information can be cut. So one of the main and most important things of the blockchain is that it's distributed. Another one regarding the security, it's cryptographically secured. One that once that you add an element on the chain, it remains on the chain. So this is why blockchain can be very useful when you work with sensible data, financial, or working with authority data, with laws, because once you put them in the chain, they will stay there. You cannot delete them. So the only thing that you can do is override them or write a new block where you will say that this law is not good, we will use another one. More than this, the blockchain is transparent, so every member of the chain can see what was written in the block. That's why a blockchain can, and that's why it is used also for the smart contracts, where participants add sensible information which has to be visible, and this is the way it works. Basically, you take the data. The data is then is creating a block. The block is distributed to all nodes. It receives validation from the validators. If it is approved, it is added on the chain. And this is, of course, as I said, each member of the network can decide if they add this block or not. As for now, the blockchain technology is expensive and heavy computational, but there are a lot of progress which is done behind by starting to work with HPC and quantum computing. So after discussing about all of these new concepts, I think a reunion of all of this can be found in the IoT, which is called the Internet of Things. So basically, Internet of Things is just like Internet, but for devices, vehicles, buildings, and so on. That's the main part of the IoT. Most of the people are thinking when we discuss about IoT about smartphones and that's it. No, the IoT can actually sustain the whole city and can enhance and will enhance the Industry 4.0. So I also want to discuss a bit about some IoT in the energy field, lighting and air conditioning buildings, control also can be used in the energy platforms to control the sensor of the consumers and on the producers. I also added a map of a smart grid, which we can think that it works under IoT procedure protocol. So we are actually having the production of the energy, which can be transferred to the consumers whenever the center will consider that it should go there. And so this is, of course, a wider picture of Internet of Things, connecting factories, production, households, electrical vehicles, and assuming that all the energy efficiency will be guaranteed by control, which is given by the data collected by sensors and AI optimization. These are some most popular application where we use AI, big data, IoT, and electrical engineering. We are having the smart grid management, the predictive maintenance, power quality monitoring, fall detection, and energy consumption optimization. And now I will go to the part 2. This is a more practical approach to AI in energy. We all know that we are facing an energy crisis. We are facing a climate crisis. We just had a talk, my colleague from Spain, that there are a lot of changes happening also in their country, also in our country. And we also know that the energy waste is a costly habit. We have some objectives at the level of Europe, which we are trying to get. The European Green Deal, also the Paris Agreement objectives, which we are trying to achieve net zero emission by the mid-century. And there are a lot of efforts put into these objectives to happen. There are good news that these things are happening. So it can be observed a rise in the shares of renewable powers. At least in Europe, there is a definitely rise. And also it can be observed that we have a lot of integration with the solar and wind power between 2000 and 2021. These are great news, but of course, as we are engineers, we know that this great news comes with great challenges. So here are the great challenges. Creating a large amount of energy not only can cause an unbalance in the network, but also can harm with energy losses. Having unexpected peaks in the demand can also damage the network. And that's why the need for data collecting and predicting the demand and the production is becoming more and more significant nowadays. So I started my research by trying to do some prediction on the Transelectrica public data energy production. And as you can see, we have some issues on the data. So I can guarantee that using, from my experience, any AI tool will be not able to predict what we can see here. So I saw this also I changed the data frame, and I saw that these errors appeared once again, which made me think that you cannot perform any predicting analysis if the data set is full of outliers. So as we had in the first presentations, it was also mentioned that cleaning the data set plays a very important part in the process of applying any AI tools in order to avoid the garbage in, garbage out scenario. So I started to look for documentation to see which are the best outlier detection methods. I've had the luck to work on the Dr. Bob demand responsive block of buildings project, which was a Horizon 22 project under the Energy Transition Research Center, and I had the access to the data which was collected with our BMS system. My surprise was that also in data collected we saw some outliers. You can see a lot just by watching, so there comes the need, if the human intelligence found some outliers, for the artificial intelligence to correct them and to make them look like a normal consumption profile. So in order to do this, we collected data from 4 public buildings. These are buildings of the university, which are the swimming pool complex, Faculty of Electrical Engineering, Faculty of Building Services, and Maraj student campus. And we did some analysis on them, and we observed that there are some small outliers which are occurring. Also, we observed a bigger one which needed an investigation. So we actually took some on-terrain action, and we went to the administration of the campus Maraj to ask what happened that year. So the answer was satisfying. They were actually renovating one of the student households. So in order to detect these outliers, as I said, I took like the best outlier detection methods from the literature, and I was surprised to see that sometimes the statistical model or the probabilistic can be just enough for some kind of data. AI is for sure the very good or the best for the large data sets, but sometimes we don't have to forget about statistical models. So I used the median absolute deviation and the interquartile range method in order to capture extremes outliers, and in order to capture the inside data outliers, we use the local outlier factor detection method, which is an AI-based method, which is comparing the local density of a point with the density of its neighbor. The same clustering principle or similar is used with the density-based spatial clustering application with noise, the dbScan. And we combine these algorithms in order to find the right outliers and to make the data clean. So here we had some results from the statistical methods that we used. We can see that they cannot detect all of the outliers. Here we can see some results from local outlier factor detection, and here from dbScan. It can be also observed, as I mentioned, that some of them are good in detecting some extreme outliers and some of them just inside the data outliers. So we decided that even these are the best algorithms to use, maybe there is still need for a human intelligence to interfere, as this part of outliers detected, they are not quite outliers. So we needed the methodology to be able to differentiate between the real outliers and the outliers that should be, which are normal energy peaks. So from expert to algorithm to innovations, we did an inside algorithm which is called custom outlier detection method, which is now part of the IP of Energia. And it's made of 4 data clusters that have been selected from the available historical data set, considering similar energy consumption values for the same hour of the day, in order to differentiate between real outliers and natural energy peaks. In order to correct the outliers, we use a piecewise cubic Hermite interpolation chip algorithm. Let's go to the results. After using the data cleaning methods and validating us through our custom outlier detection method, we validated for the swimming pool 22% of the detected outlier from the iCare median, 4.8 for the dbScan, LOF 78.5, and LOF with K3 82.1. The same procedure was done for the Faculty of Electrical Engineering. You can see in the back with the blue data is the outliers that original data were corrected, and with the red in the back, the data that is now ready to be used for different research purposes. The same, the methodology validated or invalidated the total outliers and corrected the data. Because we wanted to create a baseline to determine the consumption profile and to understand better inside the project, Dr. Bob, the events of demand response before and after. We did a social behavior analysis of each building to see the occupancy percentage during the day, during the days of the week. And then we applied the baseline, which was a KPI from Dr. Bob, to see how it worked on clean data and how it worked on original data. So basically, for the swimming pool, because of the occupancy, we did this analysis for the full year baseline, and we analyzed the standard deviation. And also we did for the summer and the rest of the year, because these are two different behaviors in the consumption of the swimming pool, summer and the rest of the year. And from other buildings, we did the same analysis for the full year consumption baseline, and we switch it here. We make it for semester 1 and semester 2. We cut the year into 2 in order to have a good representation of the baseline. The results overall visually are not very different in the clean data and the original data by having a large amount of data here in the baseline, but after calculations we saw a difference. In order to understand better and to validate that data cleaning and using AI in data cleaning is meaningful and useful, we used the ARIMA process to do forecasting for the next hour, and we saw that we have a mean difference, mean error, maybe difference of higher for the original data compared with the clean data, which it should be obvious, but it's very important to show this. We did the same exercise for the Faculty of Electrical Engineering, Building Services, and Mara Student Campus. And, as a conclusion, we saw that the standard deviation of the baseline was reduced with 0.41 on the clean data that we had, and the ARIMA forecasting process validated that the concept of garbage in, garbage out, because if we put bad data, then we will have bad results. If we put correct data, then we will have good results, and it's we have a reduction of 16% in May, which is really high. Again, I did not talk about this at the beginning. There are some people which sustain the concept of data universality, and they say that if you put any kind of AI algorithm on all kind of data, it should work. Well, basically from the AI we use on the data sets, only 28% of valid outlier detected. So without the help of our custom method, so which means that the AI algorithms need to be addressed for each specific data set and to be original for region. So these results, and of course the integration of all algorithms and so on, were part of the technological transfer. And we managed to do the first sustainability app from Romania, outlier free. We call it Renergia, and we hope to help people reduce their energy consumption and, of course, reduce their costs with energy and become more sustainable. Thank you for your attention.
Any questions? For me, it's a foreign language.
Yes.
So I'm to take outliers from that.
Correct.
By using classical linear method, our first will only can use the best side
So what I mentioned in the presentation was that sometimes the AI is not sufficient and it needs the aid of statistical and probabilistical models, which can be more useful and for some set of data sets, the statistical and probabilistic can capture the extreme outliers, while the AI can capture the inside outliers of the data. So in our case, a happy combination happened between applying statistical, probabilistical, and AI together. And then we develop our custom clustering method to differentiate between the outliers of outliers, the false outliers detected, and the normal data. No. So yeah, basically all the data is now corrected and cleaned, and all the noise was reduced, as you can saw in the standard deviation is significantly reduced. Okay.